Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. So here in this video lecture, we will understand the how to solve any logic or any expression using the programmable logic array. A very important topic for the syllabus point of view, examination point of view. So here I will make you understand for the programmable logic array, that is PLA. So this is a kind of fixed architecture which is using programmable AND gates and also the programmable OR gates. Okay, so here the point is, in PLA, this is a fixed architecture logic device, that is with programmable AND gates and programmable OR gates, right? So now let us understand how to make it. So here let's say we have three input variables A, B and C. Okay, the outputs are Y1 and Y2. These are the outputs. Okay, so we have two outputs and three input variables, right? So looking at the table, first of all, the first task is to write the expression for Y1 and write the expression for Y2. Okay, so we will write the expression here. So here Y1 will be equal to A bar, B bar, C bar, okay, plus A bar, B bar, C, plus A, B bar, A, B bar, C, and here also one we are having, that is plus A, B and C. Okay, so this is the expression for Y1. The next step is to simplify this expression. Simplify. Okay, first of all we need to simplify this expression. So here it will be Y1 will be equal to A bar, B bar, we will take common from the first two and we will get C plus C bar, which is equal to 1, and here AC will be common and B plus B bar will be coming out. So finally we have the expression Y1 is equal to A bar, B bar plus AC. So Y1 is equal to A bar, B bar plus AC, equation number 1, right? So this is the expression for Y1. Similarly, we will solve for Y2. Okay, so let us solve for Y2. Y2 will be A bar, B bar, C bar plus, here it is 1, plus A, B, C, A, B bar, C, plus, it is 1 in the last, so A, B, C, right? Now next step is we will again solve this A bar, B bar, C bar plus AC, because B plus B bar will be 1 and nothing is common, so here that will be equation number 2. Okay. So like this we will solve the given expression. The work for the table is now over. We have got two expressions, y1 and y2. Now next part. If we have got y1 and y2, so to make the PLA, the step 1 will be finding out number of input buffers. So we have three inputs A, B and C. We have three inputs A, B and C. So we will have three input buffers. Okay. So we will make it like three input buffers. We will make A, B and C. Okay. One line we will draw, and also for A bar. Similarly, we will draw for B, B bar. Similarly, we will draw for C, C bar. Like that. So we have got three input buffers we have drawn in this way. So this is my first step to make A, B and C. Here on this line it is coming A, here A bar, here B, B bar, C and C bar, like this. So for PLA this will be the first step. So this part is done. Now we need to find out number of programmable AND gates. So second step will be programmable AND gates. So that will be equal to the number of minterms which should not be repeated at all. So number of minterms here in this expression. So we have got 4 minterms, right? We have got 4 minterms, and out of those 4 minterms, if I see, because we have solved it in this way. So we have 4 minterms, 1, 2, 2 in this, 3 and 4. Okay. So 4 minterms we are having for y1 and y2. But we can see these two minterms are common. Okay. So if the two minterms are common, then we will take only one minterms as a count. That means we will need only 3 minterms. Instead of 4, we will take 3 minterms only, right? So we have got 3 minterms, A bar B bar plus AC and A B bar C bar. So here we will remove this fourth one because this was the common minterm for both the outputs. Okay. After finding out the number of gates, we will draw number of gates. So we have drawn number of AND gates, 1, 2 and 3. Okay. So number of programmable AND gates are 3, because here we are having 3 minterms and each minterm is individual in itself and no minterms is being repeated. So we have drawn the 3 AND gates to our PLA circuit, right? Now going to the next step. Let us find out what are the number of programmable OR gates. Okay. So for finding out number of programmable OR gates, we will just calculate the number of outputs, number of functions. So here if we look at the table, in this table we are having 2 outputs, y1 and y2. If we are having 2 outputs, that means we are writing 2 functions, y1 as a function of a, b and c, also y2 as a function of a, b and c. So we need to get the number of programmable OR gates. For getting the number of programmable OR gates, what we can do is, we can number of programmable OR gates will be 2 in this case, because we are having 2 functions or 2 outputs. First is y1 and second one is y2. Okay. So this part is clear. So here what we will do in this particular circuit, that we will make our OR gates. So here one is y1 and another one is y2. Okay. So this is how we will make the PLA circuit. Now this circuit is representing nothing right now, because we need to write the expression for y1 and y2. So our y1 is, see, a bar b bar plus ac, we will write here. And y2 is a bar b bar c bar plus ac. Okay. So these 2 expressions are written. Now we will make the connections. So y1 is a bar b bar. So a bar into b bar, that should go to this one. So here a bar and b bar. So the output of this will be a bar b bar. Okay, right? Because these 2 lines are getting multiplied with each other to give this particular output. Now the second is a bar b bar c bar. A bar b bar and c bar. So the output will be a bar b bar c bar. Okay. In similar way, we will make the connection for the third AND gate, that is AC. So here we will put a cross on A and one cross at C. Okay. So here we are getting the output as AC. So I think this particular step is clear now. We are having A bar B bar plus A bar B bar C bar plus AC. Now up to this point, the things are clear. For that, now see 3 inputs, and from this table we have realized the expression using AND gate and OR gate. So first step was to simplify, and second step was to get the number of AND gates, to get the number of OR gates. After that, the realization of this particular table on the programmable AND gates and OR gate. So what is the point to be noted here? We have mentioned that we are taking the programmable AND gate. So what we are doing is, here we have programmed our AND gate to give a particular fixed output. That's one. So here we can say this is my programmable circuits. So if I have made this AND gate to be programmed for giving this particular output only, so the output, the total here arrangement will be known as the programmable AND gate. This is the point to be understood very clearly. Similarly, what we will do to get this Y1 and Y2, what we will do next part will be, we will get these two outputs. Now coming to that, so here so Y1 is A bar, B bar plus AC. So put a cross here on A bar, B bar. Okay. And put a cross here at AC. Right. So the two crosses are going to the input to the OR. So Y1 will be, we need to write the entries very carefully here, plus AC. Right. So this Y1 has been realized. Now what I am doing is, I am fixing my programmer. These OR gates are also being fixed for giving this particular output, that is equal to A bar, B bar plus AC. Now next, so here A bar, B bar, C bar, A bar, sorry, this is the output for A bar, B bar, C bar, and output for AC. So Y2 will give me A bar, B bar, C bar plus AC. Now I have programmed my total AND gates and I have programmed my total OR gates, and hence circuit can be realized. So first task is to find out the number of input buffers. I will rewrite all these points. So here number of input buffers, number of AND gates, then coming to this particular part, number of OR gates, and realize the circuit using the fixed connections. So this is how we can design our programmable logic array. Thank you.